Hello and welcome to Edge Field Day. I am Craig Theriac. I'm the Vice President of Product Management at Scale Computing. I've been with the company for several years now and have been through a few tech field days with the team here, so I appreciate everyone coming back to our San Francisco office. We were founded in 2008 and shipped our first HCI product in 2012. Some of you are familiar with that product we call HyperCore, which is kind of an HCI product that pulls together storage, the compute, the virtualization that you need to be able to run applications in a highly available manner. That's also very easy to use. You can kind of see how this lends itself really well to an edge computing type deployment when you're talking about infrastructure. In the last decade that we've had this product out in the market, we've amassed thousands of customers out there across really every vertical you can think of, everything from retail and manufacturing to healthcare and beyond. And we've got some logos up here on the screen that you can see that really, I think, illustrate just how well this has been adopted by the distributed enterprises out there of the world. Those of you that do know us probably recognize us from our days servicing small and mid-sized companies, mid-market companies, where we were the easy button, as one of the delegates mentioned earlier before the presentation today, where we can easily be stood up and start providing kind of an environment where you can run your workloads without having to worry about the infrastructure itself. As we said, we're in our San Francisco office today. We're headquartered in Indianapolis, Indiana, but we do have locations really across the world. So as a global company, we can service really all sorts of different customers. So real quick, let's level set on what our definition of edge computing is, which kind of summarized in one way, which is not the cloud, not the core data center. Anything outside of that is what we would consider edge computing, and we have examples of customers that are running really everywhere across this entire spectrum, all the way out to the device edge where those people and things are connecting in. If you look at the spectrum, the closer you get to those things and people, likely the less resources you have on premises. It's also likely the lower latency that you have for those applications that are running out there. When you start to reach the edge, you start to put infrastructure out at the edge, there are a lot of issues that you can run into. I'd say the first one that I'd already mentioned is just limited to no IT resources on premises. If something happens in the environment, you don't have anyone with the IT expertise or really the tool set to be able to deal with those issues that can happen in the infrastructure. There are clearly physical constraints that are different than you might find in a tier 1 data center. There's no consistent power oftentimes. It could be hot. In the last presentation, someone mentioned grease. I've talked to customers that have said, hey, we might get fur in this. Is that an issue? Yeah. So it's things like that you just don't hear in a tier 1 data center. Consistent cooling even is another thing to keep in mind. And the physical constraints, not just the size of the device that you might actually be deploying, but it's also the security concepts around who has access to this physical device out there on the edge of the network. Connectivity and outages is another common thing that we run into where the limited connectivity that you might have to the internet might require you to run on premises, but even with that, there are outages that if you had to rely on remote connection to the internet, you just wouldn't be able to run your applications. You wouldn't be able to run those workloads on premise or connect on premises to those workloads. And then the final piece, which is something I hear from almost every team that I talk to, which is just unpredictable demands. There's a kind of a known quantity of applications that have run. I think there was a question earlier from a delegate about Windows VMs and Windows 10 and those types of applications. Those are the types of applications we see running out at the edge of the network. They're legacy applications that maybe run alongside some really cool, cloud-native container-based workloads that are doing really awesome computer vision type of workloads. But there's almost always something that's been on premises for a decade, maybe even longer, that needs to run alongside of that. And we've got a really good answer for that. The unpredictable.
I have a quick question.
Yeah, please.
Here, because you didn't mention, or maybe I missed something. Yeah. Security at the edge as one of the biggest issues. In terms of, physical security as well as logical security. Mm-hmm. So I totally understand that, there is, at least for my clients, talk about edge security as a huge issue at the moment.
Yeah, it is. You just think about the difference between a data center, a traditional data center, where you might even have a security guard standing there physically defending that area so that nobody can get in. Once they do get in, you've got all the tools that are there to lock down and make sure everything.
Is it something that is mentioned by your customers, or
as being an issue? Absolutely. Almost every single time we're talking to a customer. In fact, one of the use cases that I'll talk about later in this is a company called Ahold Delhaize, and they've got 6,700 locations around the world, and their Belgium office was looking. They had some aging infrastructure. They were looking to deploy something on premises, and physically where they're deploying these is they mount it into the ceiling. I mean, they like to joke they put it between the bananas and the pineapples, but it's physically in almost a network box up above, where physically out of reach from anybody that can get to that infrastructure. Yeah, good question. When we're talking to those customers that have said, okay, I'm part of this edge movement. I understand it's not the core data center, it's not the cloud. I've decided I need to run on premises, despite all those issues we just talked about. Here are the common leading legacy deployment architectures that we see. And I would say the first one may be the most common, which is just, you can think of this as bare metal or think of it as physical infrastructure, a point solution where every single time a new application comes into the environment, you say, you know what, application vendor, what resources does this need? Let me go out and find the hardware that I want to put that on, and then I'm going to roll a truck out to every individual site. And over time, you, number one, have a lot of friction to deploy new applications, but you also amass just a whole bunch of disparate systems that now you have to manage and monitor separately. The people that have realized that there's some value in consolidating these may have moved more to the virtualization infrastructure or 221 infrastructure side of the house, which the only difference being that you've got some form of shared storage to be able to provide resiliency in that 221 infrastructure. But you start to see some consolidation of workloads, some consolidation of being able to have all that compute accessing or accessible by the workloads there on premises. I would say all of these share one thing, which is that they're all very complex. In some of the promotional videos and conversations we had leading up to this, one of the terms that I kind of latched onto that I really liked was the difference between having a pet and having cattle. And you can think of each one of these as pet project. It's got its own feeding schedule and eats its own thing, and you got all this care and feeding that goes into it, where what you want out at the edge of the network, especially if you're talking tens, hundreds, or thousands of sites, is cattle. And if one of them gets out of line, as our VP of strategy said, you take it outside and shoot it, and then you get another one to put in its place. And that's how we like to think of infrastructure out at the edge of the network. What you really need is infrastructure that cares for itself. It needs to provide availability in the infrastructure itself. It needs to be simple to set up, simple to manage ongoing. You need some level of efficiency because every single compute cycle, every bit of RAM that you have to put toward the infrastructure running itself means that's resources away from the running applications that you might need on site. And of course, you're talking tens and hundreds of sites, that there's a cost multiplier across those sites that you have to take into account. And then finally, the flexibility to address the future needs, the unpredictable needs that I was referring to earlier. As those new applications come down the pike, you don't necessarily know what is going to be asked of the infrastructure, and so you need something that can scale out alongside the requests of that demand. And that's scaling out both within the infrastructure itself at a given site, but also horizontally across all of your sites. Needless to say, that is what we do with Scale Computing Platform. So SC Platform is kind of an umbrella term that really is referring to three different pieces of technology. Number one is, you see at the bottom of the screen here, hardware. It has to run on something, and we've certified thousands of different iterations of hardware. What I'm showing on screen here is, you probably recognize, some of you, as the Intel NUC. This is the Intel NUC Enterprise Edge Compute Edition. This is the equivalent of what we call our HE151. You'll be physically touching and feeling and seeing those here shortly. Just an example, we also have 1U, 2U rack mount servers, everything from all NVMe to tiering and all sorts of different networking flavors. So rest assured, we have a platform that will work for the use cases that you might have out there at the edge of your network. What empowers that hardware is our operating system that we call Hypercore. So SC Hypercore is what runs on top of the nodes that provides the resiliency. It's what's pulling together the storage, the compute, the hypervisor, and a lot of disaster recovery capabilities. Enrico, you had asked a question earlier about, how do you deal with things if there's a failure? This is the layer that's going to handle failures for both hard drives and nodes, as well as the entire site going down and needing to fail over to another site. This is what handles that. And then we partner that with what we call SC Fleet Manager, which is a cloud-based SaaS offering that allows you to have visibility, monitoring, and orchestration across your fleet of Hypercore clusters. So these three things combined, you'll hear me refer to SC Platform. That's just a general term that covers all of these. I kind of already covered the Ahold Delhaize case study, but I'll point out two other ones that I think are really interesting, just to give an idea of the types of environments that we see our solution deployed in. Ahold, of course, it's kind of a known entity. It's like they had their point of sale system. They had a bunch of store operations they're running on premises. Go to Northern Marine, very similar as they know they have ship operations, they've got, crew management systems and other things they had to keep online while the crew is out at sea. The big difference, obviously, is that these are going on a vessel, and that vessel's going out, in international waters that has limited connectivity to the internet. It needs to be able to be autonomous. It needs to be able to run separate from this. I mean, as they were quoted here, is they need to be able to sustain equipment failure and still continue to operate. Very similar in terms of they needed availability in the infrastructure, but very different in terms of how they interacted with that infrastructure. Obviously, what they also share with Ahold Delhaize is limited to no IT resources on premises. Now, the last one that I'll bring up was Resorts World Las Vegas, which is a 117,000 square foot facility on the Vegas Strip that has, I think, 3 hotel brands associated with it. It's a gambling facility. They are using scale computing as the back end for their surveillance system. So they're running a VMS on top of us with Milestone. And they're also doing some really interesting things around computer vision and being able to look at license plate recognition and being able to do things with that data in real time. And while they only have a single location, it is fairly large. And they do have some IT resources, but not as many as you'd think. In fact, we had a conversation with William Adams just last week at our platform event in Vegas, and he told us that they have a total team of 5, including him, and 4 of them are usually out trying to corral all of the cameras that they have on premises. They're looking to deploy 14,000 cameras, and I think at the time of at least the case study, it was around 4,500, and when I spoke to him last week, it was closer to 6,000. So kind of give you an idea of the depth and scale and breadth of the possible solutions that you might see out at the edge. In addition to those 3, I'll just point out, we have thousands of really happy customers out there, evident in the Gartner Peer Insights and Spiceworks and Trust Radius and Tech Validate and G2 reviews out there, and we welcome people to go out and look at that. I would also want to point to one that I'm really proud of, in addition to the product being really solid and customers going out to tell the world about how great scale computing is. We also just received for the 4th year in a row our second, the 2 category winner for CRN's annual report card. So we are a channel first company. Everything we sell goes through distribution and usually a reseller or an MSP to an end user, and they're the face of our product to the customers. And so we work hand in hand with those partners that are watching today. I welcome you to talk to us and see this firsthand, but this is voted on by those partners to tell the world that the product, the service, the people, everything about scale computing works really well with the channel. And I think Scott Loftmuller in his presentation, when he talks about the autonomous infrastructure management engine, is going to really dive into the finer points of this report card.
In that first column on that last slide, do you think the category of desktop and server virtualization is becoming more of a legacy term?
I do, actually. I mean, with every term, it's people. I mean, actually, as I was going through the slides here today, you'll find one that says fog. You'll never actually hear me use the word fog. It's kind of a meaningless term. And I think over time, terms like this do become a little meaningless because it doesn't really matter if it's a desktop or server or if it's virtualized. It's like, hey, there's a workload, you need uptime in your environment, and here's a platform to do that on. I think the only difference you might see out there is people referring to VMs versus containers. Although I would say in the next few years we're seeing a convergence between those 2 technologies. Where you see people running VMs within containers, you see people running containers within VMs, you see Kubernetes orchestrating that, you see companies like Avasa orchestrating those containers as well, whether that's on bare metal or whether that's in a VM. And so there's a whole bunch of things going on where I would say as of right now it's starting to become legacy, but I think over time you'll probably won't even hear it referred to. Much like hyperconverged infrastructure, I think it's another term that over time you won't hear as much about. It'll be, you want cloud resources, where do you want to run that, on-prem or in the cloud?
After the VMware acquisition, did you see any uptick in demand from, customers that are usually VMware shops and now, are rethinking a little bit their strategy, not only at the edge, but in general?
Yeah, across the board. I think there's a mandate from on high. I mean, if you... Not to bash any competitors out there, but if you actually go look at the Broadcom announcement on this, they really touted their strategy for making this a successful acquisition, and it was really to focus on the top 600 customers, which generates the majority of their revenue. Makes sense as a business plan, but you can see that's not how we operate at Scale Computing, and so there's an opportunity for us now to take the non-600 top customers and say, welcome to the Scale Computing family. Let's make you have a successful deployment. I would also say that it was a question in the last session about, who do you typically run into, or what's the common pushback that you might receive from an end user? And it's usually they've used VMware their entire career. And it's, can I really do all the things that you need to do in a VMware environment with scale computing? And the answer is yes. And so having that answered ahead of time and saying, yes, we're a really good platform to fall onto from VMware, plus this news is kind of an impetus from externally pushing people to even explore outside of VMware, we're seeing a big uptick.
So Craig, you may have answered this already just now, but I want to ask it a little bit differently. But are you seeing people actually start to abandon VMware, or at least consider abandoning VMware for scale, or are they looking at, okay, if we're have all this uncertainty around VMware and Broadcom, do we just start thinking more about public cloud or something like that? What are some of the trends you're seeing, if any, because of this?
Yeah, so it is similar to, I think, what Enrico was asking, but I think the one difference in how you're asking is, are they considering things outside of us? And the answer is yes. I would say anytime there's a big shift where the gorilla in the industry is getting acquired, it makes you second guess what you want to do with that application, that workload, your infrastructure. And so when people are coming to us, they've already decided, hey, I do need to run this on premises. The four major drivers that we see, well, I'll call it a fifth major driver that we see for people running on premises are latency, obviously. Bandwidth is a big one. That the video surveillance use case, they're just generating so much data. You can't do that in the public cloud. We see people that have regulation requirements. They've got, some kind of personally identifiable information that they're generating that need to run and live on premises. And then the connectivity, right? So the ship's going out to sea. If they don't have connectivity, they need to run something on premises. The fifth one that kind of is the unsung hero of all of it is legacy applications, and the cost of refactoring those to actually be cloud native is going to prevent a lot of people from ever considering the cloud. So I think what is happening, and what I'm seeing, is that acquisition is forcing people to question what they want to do with it, and then they make the determination, do they fall in one of those five categories? If yes, then they have to run on premises, and then that's where we enter into the discussion.